Let's talk about data creation. I will first give an example of crowdsourced label creation for training machine learning models. And then we will discuss an important topic in this area, namely how to reduce the amount of labeling work without sacrificing model performance. The most well-known story of human computation for machine learning data creation is perhaps ImageNet, which is a large-scale dataset of natural images annotated with object names. In an ImageNet contest in 2012, Geoffrey Hinton, together with his two students from the University of Toronto, submitted a deep convolutional network called AlexNet, which beat the field by a margin of more than 10%. That was the first time machine learning performance reached an error rate of less than 25%. What happened next? Well, most of you might already know these convolutional neural nets are everywhere nowadays. Facebook uses them to tag our photos. Self-driving cars are using them to detect objects. Basically, anything that knows what's in an image or video uses convolutional nets. The success of convolutional nets, in fact, to a large extent, can be attributed to the ImageNet dataset. Those neural nets come with a large number of parameters that need to be learned from a big amount of data, and ImageNet is a dataset that, for the first time, fully demonstrated the power of such big neural network models. And also because the data is big, the evaluation is more reliable. The co-inventor of AlexNet said that it was so clear that if you do a really good job on ImageNet, you could solve image recognition. Well, nowadays people realize that this is only partially true, and we will come back to that later. But still, ImageNet indeed has been the best dataset ever for evaluation. ImageNet has since then been viewed by many people as a catalyst for the AI boom that we are now experiencing today. In fact, most progresses in computer vision are marked by the improvement of model performance on ImageNet, and today the error rate has been reduced to less than 2%. Along with the advances of computer vision techniques, the value of a well-constructed dataset has been more and more recognized. Fei-Fei Li, who was co-inventor of ImageNet, said that the paradigm shift of the ImageNet thinking is that while a lot of people are paying attention to models, let's pay attention to data. Without a good dataset, you cannot know whether or not the model has reached the best performance, and you don't know whether or not the improvement of modeling techniques is real. Now let's take a look at how ImageNet was created. Creation for the dataset was motivated by visual recognition tasks. In these tasks, we want to train some machine learning models that can recognize unknown objects in an image. For example, whether there is a dog in the image. And sometimes we want to know more specifically. For example, we want model to not only tell if there is a dog, but also what kind of dog it is in the image. This is a hierarchical classification task, but the goal is to find the right concept in the taxonomy. The task is rather complex if you consider how many kinds of objects there are in the world. Take, for example, a famous database of English, WordNet, that contains all the nouns, verbs, etc., and encodes the relation between concepts. For example, husky is a subcategory of dogs. Overall, the WordNet thesaurus contains over 80,000 concepts or synsets in WordNet terminology. In order to train models to recognize objects in the open world, we need to collect a big number of images and have them annotated. And this is not only because of the large number of concepts, but also that we need to collect not one, but a lot of images even for one concept. Because machine learning models learn from examples. If we have just a few examples, the model cannot really learn what are the useful features for object recognition. ImageNet is a large-scale ontology of images built on top of the backbone of WordNet structure. It contains 500 to 1,000 images for the majority of the 80,000 WordNet concepts. Here in the example, you can see that images are associated with the WordNet branch that ends with the concept Husky. You can see images of Husky specifically and images of a parent category of Husky, namely working dogs. So you can see all the images of working dogs other than Husky. How exactly was the dataset created? Well, ImageNet was constructed in a two-step process. In the first step, images related to concepts in WordNet are retrieved from the web, and since the accuracy of the retrieval is very low, meaning that we don't always get images of Husky if we search for Husky. So in the next step, the images were cleaned by humans to verify if an image indeed contains the concept that was searched for. If we go a little bit more into the detail, for the first step, initially, the image retrieved was often quite limited in terms of the size. To get enough images, the creators used some information retrieval techniques, such as using all the synonymous words expressing the same concept to query images, and further expand the queries by appending words from the ancestors of the concept in WordNet. They used multiple languages to get more images, and in the end, the accuracy was less than 30%, meaning that 30% of the images matched the concept that were searched for. And this necessitates the second step, right? Human verification. Feifei Li did a calculation and found that if she asked graduate students to annotate the 3 million images, it would take 19 years. But luckily, they found Amazon Mechanical Turk, which in the end allowed to annotate more than 3 million of images in just 5 months. Here is how their annotation interface looks like. In each of the labeling tasks, workers were presented with a set of candidate images, and then also the definition of the target scene set, including a link to Wikipedia of that scene set. Workers were then asked to identify images that contain objects of the scene set. A big challenge using crowdsourcing for data labeling is label quality. In the specific context of image annotation, some scene sets are hard to get right. Now, on the right hand of your screen, there is an example of verifying Burmese cat in an image, which is rather difficult for many non-cat people. Now, for this issue, links to Wikipedia will help a lot. Another cause of low quality labels is that some of the workers do not read the definition carefully. Now, to deal with this issue, Feifei Li used a quiz to check if workers understand the concept. And in the end, you can see that they got quite okay accuracy. And this is the story of ImageNet. I hope this story gives you a good idea of the importance of data in AI and the unsung hero who creates the data, the people.